Alright, I wanted to do one of the trickier problems like we did in class the other day, just to show a group of vectors that are not all lying in the x and y planes. So if we consider an object that has moved 25 units to the east, 15 units to the south, then turns and goes 44 units at 26 degrees north of east, this is north of east, and then turns and goes 20 units due north. This is our object's motion, and so what we want to do is determine what is the resultant. Now, a resultant can easily be diagrammed by simply drawing from our first tail to our last head, so this is going to be the resultant eventually. Let's slide my ruler there. Okay, so this is our resultant. And I want to find the length of that line, and I want to find the angle to which it is sitting. So here's what we're going to do. First thing I'm going to look at is this angled vector. I want to break him into his components. So I would see that I have an x component that lies along this axis, and I have a y component that lies along this axis. The size of this, or the magnitude of this component, is going to be 44 times the cosine of 26, and then the size of this one is going to be 44 times the sine of 26. If you put that together and punch those numbers in your calculator, you will get that this is a 39.547, and this is 19.288. And if you want to check your work, you can just pause and then do that calculation, make sure you're getting the same thing we did. Now, having these two vectors analyzed, this guy is no longer of any importance to us. This 26 degrees is no longer of any importance to it. We've got those guys right here in this component and this component. So now I'm going to go and form my xy table. So here are my x values and my y values. On the x-axis, I've got this first vector, which is 25 to the right. Since that's positive, we'll leave him as a positive direction. We have this x component, which is 39.547. Remember, I'm carrying out extra sig figs just because I don't want to round too soon. And that's the only two that sit in the x. In the y, I have this vector, which is negative 15 units. I have this vector, which is in the opposite direction. It's a positive 19.288 units. And then this vector, which is 20.0 units. And so if I combine those things, then what I'm going to find out is over here I have a 64.547. And here I have a 24.288 unit in the y. Okay. At this point, I now have a new x and a new y system. I can draw those out in a simple triangle, or I can recognize that that is going to be this distance and then this distance. Remember that this 25 is not an angular measurement, it's actually the length of this vector. So I'm going to cross that out and say my new x, this is my 64, lies right along this axis. So that's my 64.547. And then from here up is my resulting 24.288. All right. To get the length then of this resultant vector, I'm going to use the Pythagorean theorem. The hypotenuse is going to be equal to the 64.547 squared plus the 24.288 squared, and then we're going to take the square root of that. And I'm going to punch that into my calculator real quick, make sure that I have the right values. 64 point. And that gives me a hypotenuse value of 68.965, or to 2 sig figs, we'll just call that 69 units. So this value is 69 units. For direction, this is the angle that I would like to discover. The value of this becomes my theta. And so as we have always done, I'm going to use the tangent to the -1, the inverse tangent of the opposite, which is the 24.288 over the 64.547. 64.547. And if I punch that into my calculator, what I find is I get an angle of 20.62 degrees, or 2 I'll just call that a 21-degree angle. So that is 21 degrees. So it's 69 units at 21 degrees, and this is sweeping out an arc to the north of the east axis. So that is my resultant value, 69 at 21 degrees north of east. Okay, if you have any more trouble with this kind of a problem, please come and see me. We can sit down and talk about it. I can give you some more examples, and we can figure it out.